Hello, MJ7NLK here and welcome back to the channel. Whilst we're waiting for President to release the George 2, which is due in late September, I thought I'd keep myself busy and build a ZX Spectrum clone. It's a Harlequin 128k build and I had lots of problems with this one, so do stick around to watch that. But first, we're going to hear a word from our video's sponsor. This video is sponsored by PCBWay, makers of prototype PCBs of all kinds. They also offer services such as PCB assembly, CNC machining, 3D printing, sheet metal fabrication and injection moulding. Manufacturing times are exceptionally quick and delivery is super fast, so please do check them out in the description below. Before we get started with the build, I wanted to share two items that I found when opening this 48k Spectrum that I purchased from eBay. Inside the box were the usual manuals that you get with a Spectrum, the introduction and basic programming guide. But inside the box were two other things. There was this hand-drawn map, which you should be able to see. Let me see if I can zoom in a bit on that. So there was this hand-drawn map, which I'm reliably informed is the map of Jet Set Willy game and all of the different rooms that you can go into. So I thought that was a nice little find. And I also found in the box a price list. So this is from Granada Home Computers Retail, and it was produced on the 28th of November 1983 and is issue number 6 and contains the prices for not only Spectrums but also Commodore, Dragon, Sanyo, Auric and Atari. And if that wasn't enough, if you turn it over, there's a whole load of prices for games and items as well. So I'll take a proper copy of that and I'll flash it up on screen and then we'll get into the content.
One man and his stupid dog, a Hakko soldering iron, and a bag of parts. What could possibly go wrong?
Welcome to the Superfo Harlequin 128 build, and this is an issue 3H board from March 2020. It is a ZX Spectrum clone based on the Harlequin by Chris Smith. You can find out more information about the Harlequin at his website zxdesign.info. The board has been supplied by PCBWay and more info can be found in the video description. I used the default settings on the website when ordering with two exceptions. I changed the colour to purple and white, and I changed the amount of copper per square foot from 1 ounce to 2 ounce. My thinking here was if the traces were thicker, they would be less likely to lift or tear in the future if rework was required. I could be completely wrong here, but we will have to just give it a go and see how this works out. There are about 50 chips on this board, and the board measures 21 cm by 13 cm to match the original Spectrum PCB. It's densely packed, but should be a fun build. There is only one SMD chip on the board, and this is the video encoder, which is an AD724JR located at the bottom left. In comparison, this is a remake of the issue 3B ZX Spectrum board, and you can see it has about half the number of chips and is less densely populated. I probably should have started with this one, but anyway, back to the Harlequin. You can find all the information needed on Superfo's GitHub page. There is also an issue 4A from December 2020 and a 4B from January 2023. I wanted to build the 3H as I was intrigued by the IDE interface. But it's only now that I've realised it's not much use, as I won't be cutting a hole in the side of the 48k Spectrum case. The latter two revisions don't have the IDE interface, so it looks like it's been depreciated. Anyway, the bill of materials is on the GitHub page to help you track down the parts needed. Talking of parts, Here they are, freshly from Digikey. It is so time-consuming ordering the bill of materials, especially when parts are no longer available. You end up having to order from multiple suppliers, and I had to revert to Mouser and eBay for some of the items. The sound chip took a bit of tracking down, and I eventually got one from Retro Lemon, which is the AY38910 Yamaha chip, and I was sent the YM2149F, which is a clone of the AY38910. Now let's talk briefly about sockets. We have turned pin sockets or dual leaf sockets. Turned pin sockets have a tapered entry and allow for 4 points of contact. They offer a more reliable electrical connection as they can tolerate higher voltages and currents. Dual leaf sockets have a simpler design and are commonly used in circumstances where automatic machine insertion is required. Turned pin sockets tend to be double the cost of dual leaf sockets. This 40-pin turned pin socket is around £1.30 and the dual leaf around 68 pence. I much prefer turn pin sockets. They have more substantial pins and are less prone to damage and are slightly less bulky. However, I can see an issue with the Harlequin layout on the sound chip U54 and also on U8. They have chips soldered directly to the board that are inside the socket. I might get away with a dual leaf for the sound chip because the support of the socket is in the middle. Might get away with that. But I certainly won't get away with it with this particular turn pin socket because it has two supports. So I think the best thing for us to do when we get to the sockets and the chips is to solder U41, 42 and U7 directly to the board so that we know what adjustments are required to the sockets that are going around them. I don't have any 6, 8 or 32 pin turned pin sockets at the moment, but think I have all the others needed. So what I like to do first is to group the components into relevant bags. This bag contains ICs. Any chips will be in here. This bag contains any connectors, sockets, switches, crystals, etc. In this bag I have all of the capacitors, whether they're ceramic or electrolytic. In this bag I have diodes, and this is where we're going to be starting, which is resistors and resistor arrays. So we're going to start with the 10k resistors first, and there are 16 of these sort of spread over the board. So I'm going to use my component bender and put those in now. I didn't buy a kit, so don't have any handy-dandy instructions to follow. I am using the bill of materials and the component references to find out where they go. I cleaned the board with IPA before starting and have now positioned all of the 10k resistors. The next step is to flip the board and solder them in place. Ensure that when fitting the resistors that you spread the legs out behind on the back of the board so that when you flip the board over, the resistors don't fall through. So let's get on and solder them in place. Well, here's a little tip that you might find useful. When cutting resistor legs or any legs off components, I use one of these, which is a normal terminal that you would put on the end of a wire, and just pop it over the top, and it makes sure that I don't cut it too close to the board. And the good thing is that if you use one of these, which is quite a large diameter, you can cut two resistor legs which are right next to each other at the same time. So it's quite handy. So that's the 10k resistors now on the board. We're going to have a look at the 470 ohm next, of which there are 19. It does actually take quite a while to find out where they all go, but I'm going to find them, put them in the board, and then we'll have a look at the rest of the resistors. So there's a lot of these 470 ohm resistors, and we're just going to go through doing one of them now. So we push the resistor, which we've pre-bent, through the hole, turn the board, bend one of the legs. Solder the vertical leg, pull the other leg up, trim them. Spin the board and make sure that the solder has flowed all the way through. And repeat another 18 times. So that's all the 470 ohm resistors in place, and I'm just going to press on and get all of the other resistors onto the board. Well, that's all the resistors in place, and I've also fitted the resistor arrays. Just be careful when soldering and remember to clean your tip each time, as it's very easy to block an adjacent hole. This happened to me twice and I had to break out the desoldering gun. Or the moo machine, as my friend Lee from More Fun Making It calls it. I hope you don't mind me borrowing the name. Next we will fit the diodes and deal with the diode array at DN1, which is not covered on the Github page for the issue 3H, but luckily there is a diagram on the issue 4 pages which has given me the information I need. On to the diodes. There are 22 general purpose diodes located in various places on the board. There is also one optional Zener diode for the RS232 option and 5 more general purpose diodes for DN1, which is a diode array. The diodes are tiny and it's important that you get them the right way round. I won't be able to show them, they're too small, but the diode has a black ring at one end which denotes the location of the anode. It's important that these are matched up with the silk screen, and on the silk screen there is a little line to denote which way round the diode should go. The general purpose diodes have now been fitted to the board. Next we need to address the DN1 item. I have soldered a diode into the last hole of DN1 and bent the cathode leg and inserted into the first hole. Next I need to insert diodes into the remaining 4 holes, soldering the cathodes to the bar I have created. Well, it certainly won't win any awards for beauty, but that's what it says to do. So let's move on. Next we need to look at the SMD chips. The first is U32, which is a MAX 3232 CDR and is an RS232 line driver receiver. I couldn't find the location on the board at first and then realised it's soldered to the underside. I have already soldered this in place and checked the legs to ensure it's on properly. The second chip is U48, which is an AD724JR. This is the video encoder, and that is the next item to be soldered in place. Well, that was a bit of a nightmare. I soldered the RS232 chip by drag soldering, but for the video encoder I broke out my hot air station, turned it on and it started heating up and then failed, so it's broken. So I don't have a working hot air machine at the moment, and I had to improvise with the hot air gun, and that was not pretty. The chip is now on, but I have inadvertently blocked a hole behind the video encoder. So that one needs to be sorted out next, and then moving on to capacitors. Well, here we go with the capacitors. So we have ceramic caps, electrolytic caps, we have some SMD caps as well, which need to go on the board for the RS232, and we have some transistors. So I'm going to start with the easy ones, and that's the ceramic caps. Ceramic capacitors fitted, now on to the electrolytics. That's all the resistors, capacitors, diodes and transistors fitted to the board. Next we've got sockets. Sockets have now been populated. I didn't have a 32-pin narrow dip socket, so I used two 16-pin instead. I also didn't have the standard 32-pin or 8-pin turn-pin sockets, so I used dual leaf for these. I fitted the two HC257 multiplexers and the HC174 flip-flop directly to the board. I really don't like soldering chips directly to the board, but there really is no option here due to their placement. I then cut away the central supports from the dip sockets and soldered these in place. I used my trusty Leatherman multi-tool, and the file on this worked a treat. Next we need to fit the switches and ancillary connectors before we get to the fun bit, which is populating all the chips. Well, that's it. All ancillaries have been fitted to the board, and it's now a struggle to get in the jig. Next up is chip fitting time. If lots of lovely logic chips float your boat, then grab a box of Kleenex, sit back and enjoy. Well, that's it. The board is fully populated, with the exception of the ROM. This ROM needs to be programmed before we can insert it into the machine. So that is what we're going to do next. It's now time to deal with the ROM. The bill of materials said to order an SST39SF040 ROM, which is a CMOS multi-purpose flash. It's a 4 megabit chip organised by 512k x 8 in a 32-pin DIP package. In order to program the ROM, you're going to need a programmer, and the one I am using is a GQ4X4 Universal Programmer. There is a USB driver to install first, and then the software to install, and in this case it's called USB PRG, which is all downloaded from the manufacturer's website. The first step is to connect the programmer to your computer and insert the ROM for programming. Now, I happen to know that this particular ROM in the programmer goes in the bottom pins of the ZIF socket. First, we need to load the software. Next, we need to select the device. And this device is the SST, and it's the 39SF040. You can add it to your favourites if you wish. We're now ready to program the ROM. Now you need to select the ROM image that you're going to burn. And here it's Superfo 128 29F040, and this can be obtained from the Github page for the issue 3H. Just say OK to this screen. Next, we need to write this to the chip, so click on the Write button. The process has now completed. You can click on the Buffer tab to see the image that's been written to the ROM. We're now ready to insert the chip into the board. I don't have the MIDI 9-pin DIN cable required for video output, so I'm going to have to hope that my ZX VGA Joy will do the trick by inserting it in the cartridge slot for video output. So let's get this hooked up and see if we have a booting machine. We are ready to turn on the Harlequin for the first time. I'm using a VGA Joy to output the video and have plugged the audio in as well into my scan converter. Before we plug it in, a word of warning on the power supplies for Spectrums. These are center negative, which is different to most normal power supplies, which are center positive. Plugging a Spectrum power supply into another device could cause it permanent damage. I have set the dip switch to off, 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 which selects the diagnostics ROM bank in the ROM. Always a nerve-wracking moment, but here goes. Yes, we have a working computer. But it looks like we have some issues. So we have a lower RAM error. You can ignore the references to the ICs that are shown there. They are for the normal 48k Spectrum, which has multiple RAM chips. And we're now going through the upper RAM test. And we'll see if the upper RAM passes. Fingers crossed, here we go. Yep, upper RAM is good. And we'll jump into the audio test. Okay, so we have audio, that's good. So I will just mute that. Okay, so let's talk about the RAM. So we have the upper RAM chip here. Well, I believe it to be the upper RAM chip, which is the AS6C1008 chip. We've got the CPU here, the sound chip here, the ROM here, and I believe this is the lower RAM chip, which is a UM61512. Now I have quite a lot of these, so I can quite easily swap that out for another one and see if the RAM error goes away. There's not a great deal of documentation on what all the chips do for the Harlequin, but all of these chips here are logic chips. They are 74HC chips, and they're in place of the PLA that the normal Spectrum has. Okay, let's swap it over. And power it on and see what happens. Testing the lower RAM. I think we might still have some problems. We do. We still have an issue. As I'm not 100% sure on which one is the upper and lower RAM, I'm going to replace this chip as well. Now, I've had to remove it because it was quite difficult to get out because of the placement of the resistor array at the back. But we're going to replace it and see. Nope, we still have an issue. Let's just check the upper RAM. So upper RAM is testing. So I think we may have a connectivity issue here with one of the sockets. So the next thing I will do is to reflow the solder joints on those two sockets. Upper RAM tested okay. So that's what I'm going to do next. Well, I now know what the problem with the lower RAM was. It wasn't the lower RAM. Recognize this? Well, this is the original board that we were working with, and I tried everything to get the lower RAM to work, and it just was not having it. So I thought what I'll do is this is the lower RAM, by the way, and this is the upper RAM. I got them the wrong way round earlier. So I was trying to remove the chip that's soldered directly to the board. My hot air station is broken, as I mentioned earlier, and it's on me, really. It was really stupid to try and remove that chip that was directly soldered to the board without hot air. And I lifted a trace. So, really annoyed that I lifted a trace from the board, but, I could patch it, but I don't want to patch it. I want this to be perfect, and I've decided to scrap this board and to build another one. So I was merrily fitting the resistors to this board, and I was working from this pack. I'll put an image on the screen and you can see the part numbers, etc. And it says on this pack it's a 470 ohm resistor. Well, I ran out of these and I went and grabbed another bag, which is identical part numbers and 470 ohm resistors. And these resistors are a different colour. So I've tested the original ones that were in there, and they're 470k resistors that were supplied by Digikey in a bag saying 470 ohm. So that's why the lower RAM wasn't working. All of these resistors here are wrong, and they sit between the lower RAM and the CPU and the ROM. So that's why it was not working. So I'd already fitted 5 to the new board, so I've removed those 5, and I'm now merrily working my way through the remaining 19 in total that need to go on. All the SMD components have been fitted, both sides to the board, and we're making progress. I have ordered a new hot air station. It's on its way. Whether I'm patient enough to wait for it to arrive and whether I get the painters and decorators heat gun out again to remove these sockets, I don't know. But I could fit dual leaf to the new board. But at £1.50, £2 a socket for the turn pin, and being almost 50 of the damn things on the board, it's too much money to waste. So I'm going to try and see how I get on with the gun to remove these. I've removed the resistor, the diode array over. So, the complicated bits have been moved. I've just got to try and salvage these sockets if I can. But, lesson there for everyone. Just because they supply a part and the bag says it's 470 ohm doesn't necessarily mean it's 470 ohm. And the big telltale was the red ring around the resistor, which I should have spotted, but I didn't. So that's this. That's the update. I'm going to keep going on this board and see how much progress I can get done to get back to the position I was in before. Here is the second board completed. Let's take a good look and admire the hard work. I have ticked back every component on the board and validated all the values of the resistors and caps. So this board is now ready to be turned on for the first time. Testing lower RAM. And we have a lower RAM pass, which is excellent. Upper RAM pass. And into the diagnostics menu. So via the VGA Joy, we have a working system. Let's try the 9-pin DIN. So the VGA Joy's been removed, the 9-pin DIN connected. Let's boot this up and see what happens. Okay, we've got an image, but it's pretty dirty. Got something going on. The difference in picture quality between the VGA Joy and the RGB output is really quite striking. This is a fantastic device, it really is. Okay, so lower RAM passed. We're now doing the upper RAM test. Okay, RAM checks passed. And, oh, yeah, that looks a bit of a mess, but it's supposed to be the diagnostics menu. Okay, so I think what I'll do next is the U28, which is a 74HC32. I'm going to try an LS version of that chip and see if that makes any difference. So a 74LS32 is now in U28. Let's give it a go. Well, the RAM checks pass again, and we have a mess on the diagnostic screen. So something is not right. I'll swap this back, and then I'll do some basic troubleshooting. I may replace the transistors just to see if that makes any difference, and see if we can get a clean output through this RGB. So I've done a few checks. I've removed and replaced the video encoder, the AD724JR. I've removed, checked and refitted the transistors. Everything is fine there. I removed the 75 ohm resistor and the 220 UF cap on the blue pin line 1 of the Mega Drive 2 SCART cable, as recommended in the documentation. I've also checked a different Mega Drive 2 cable with no success. I've probed around the board a bit with the oscilloscope to see if I can see anything obviously wrong, but without having a working Harlequin, I don't have anything to compare it to. So I'm a bit stuck at this point. So do you have experience with the Harlequin 128k board, and in particular this 3H revision? Have you seen this problem before? Well, if you have, please jump on the comments section and let me know. And I'll do some more research, but this video is getting a bit long now, so that will have to be in a part 2. Well, that's it for this video, part 1 at least. If you happen to know what the problem could be, then please do help out and drop a comment in the comments section below, and we'll see if we can get this Harlequin 128k working. Well, that's it. So stay happy, stay safe, and catch you in the next one.